You ever wonder what secrets might be hiding in a perfectly ordinary day? You know, if you just pick one at random, you might just find a thread that connects some of the biggest stories in science and history. And today, well, that's exactly what we're going to do.
Okay, so what could possibly connect these three things? I mean, at first glance, they seem totally unrelated. You've got a huge award, a math problem that stumped geniuses for thousands of years, and a word we use all the time. So what's the link?
Yep, that's it. They're all connected by one single random date. Today, we are pulling back the curtain on March 6th, and you're going to see this hidden network of brilliant minds and absolute breakthrough moments.
All right, so for our first story, let's jump into one of the most famous challenges in all of mathematics, the quest to square the circle. For over 2,000 years, people tried to construct a square with the exact same area as a circle, using only a ruler and a compass. Sounds easy enough, right? Well, not so much.
Now, to really get why this was so tough, we need to talk about something called a transcendental number. And don't worry, don't let the name scare you. Basically, think of it this way. An algebraic number, like the square root of 2, can be the answer to a pretty simple equation. A transcendental number can't. It transcends algebra.
And this is where our guy, Ferdinand von Lindemann, steps onto the stage. Now, he passed away on March 6, 1939, and we remember him for delivering the final, definitive word on this whole puzzle. He proved that the most famous number of them all, pi, is transcendental.
And that was the final nail in the coffin for this ancient puzzle. See, to square the circle, pi would have had to be one of those algebraic numbers, but Lindemann proved it just wasn't in that club. And here's the crucial part. He didn't solve the problem. He proved it was impossible to solve. A 2,000-year-old mystery finally put to rest. Game over.
But the story of March 6th isn't all about these huge, famous proofs. It's also about the quiet, brilliant work of people who maybe history has overlooked. You know, the ones who laid the groundwork and taught the next generation without all the fanfare.
So let me introduce you to Annie Hutton Numbers, born on March 6, 1897. Just look at this resume. Multiple degrees in math, philosophy, chemistry. She became an assistant lecturer, earned a PhD, and dedicated her life to teaching. Her work was praised for its method and efficiency. She was clearly a force.
So you have all this incredible academic achievement, right? And then you see this dedication from her niece's book. It celebrates her, for sure, but it also frames her as one of the spinster generation. It's just a really powerful reminder of the personal stories and the societal pressures that are so often hidden behind the names and dates of history.
Okay, so let's switch gears and talk about how knowledge gets passed down. Because, you know, mathematics isn't built in a vacuum by some lone genius. It's really a conversation across generations, a chain of influence where teachers inspire students who then become teachers themselves.
And you can literally see that chain right here. It's amazing. Look, you've got the great analysts Betty and Dini. They teach Cesare Arzelà, who was born on March 6. Then Arzelà turns around and teaches Hector Bortolotti, also a March 6 birthday. And he goes on to teach the first ever course on Galois theory in Italy. And in that last row, Alexander Kotelnikov, who died on March 6, carried on the legacy of non-Euclidean geometry, a field his father's colleague, the legendary Lobachevsky, helped create. It's this incredible web.
You know what's really amazing about looking at a single day like this? It's the sheer variety of stories you find. There's not just one way to lead a life in math and science.
So take these two guys, both born on March 6th. On one hand, you've got Ettore Bortolotti, the classic academic, a professor, a historian, digging up lost manuscripts from the 16th century. And on the other, you have Edward Blades, a public educator who became a director of education and helped organize army education during World War II. Both of them were totally dedicated to knowledge, just in very different arenas.
Wow, I mean, this timeline really drives it home, doesn't it? This one day is connected to the very word scientist coined by William Whewell. It's connected to Lindemann's proof about pi. Then, in 1938, Hans Bethe figures out how stars generate energy, how stars work, which won him a Nobel Prize. And in 1966, Helge Tverberg publishes a theorem that becomes a cornerstone in its field. It's just an incredible sequence of breakthroughs.
And listen, these aha moments, they don't always happen in a stuffy library. They are so human. Here's Helge Tverberg, born on March 6th, talking about his big discovery. It wasn't in a lab. He was shivering in a cold hotel room, couldn't get back to sleep, and suddenly, bam,
the solution just dawned on him. What a great reminder of the weird, wonderful way genius can strike.
So, to wrap things up, I want to leave you with this thought from the Nobel laureate Hans Bethe, who passed away on March 6, 2005. He talked about the spirit of physics, the idea of discovery, the idea of understanding. And really, that's it. That's the common thread here. That's what ties all of these March 6th stories together. That relentless, fundamental human curiosity about how the world works.
So we've pulled on this one little thread, March 6, and uncovered this whole incredible tapestry of stories. Which really makes you wonder, doesn't it? Whose stories are hidden in tomorrow's date?